Three- and four-way switches are found in typical circuits in your home. For example, a three-way switch is often used to control a single light source in a room from two different wall switches. Each of the switches works independently, allowing you to turn the light on or off from two different switches in the room. In this diagram, depicting the operational components of a three-way switch, we have a typical 120-volt source and two single-pole double-throw switches controlling a load, or in this case, a light bulb. This type of circuit has a black, red, and white wire handling the current. In this first switch position, both switches 1 and 2 are up. The current flows through and lights the bulb. If you place switch 2 in the down position, while switch 1 remains in the up position, the circuit is broken and current does not flow to the light bulb. This would be the same as turning a ceiling light on using a wall switch as you enter a room from one door and turning the light off as you throw a switch when leaving the room using another door. The switches can also be in a down position, in which case current flows and the light is on. Or switch 1 can be down and switch 2 up, in which case the circuit is again broken, no current flows, and the light bulb is off. Experiment at home with switches that control a single light. Have someone operating one switch while you operate the other. Think about the switch positions as you turn the light off and on. In this four-way circuit example, we have two single-pole double-throw switches on the left and right, and a double-pole double-throw switch in the middle. If switch 1 and 3 are in the up position and the position of switch 2 connects the same colored wires in the circuit, the current passes through the black wire and lights the bulb. If the position of switch 2 remains unchanged and switch 1 is up while switch 3 is down, the circuit will be broken and current will not flow through the circuit to light the bulb. Placing switch 1 now in the down position and switch 3 in the up position also results in a broken circuit, and current is unable to flow freely to the light bulb. If we keep switch 1 and 3 in the same positions and throw switch 2 into the crossover position, a complete connection is once again established and current flows through the red wire to the black wire to power the light bulb. If we change the position of both switch 1 and 3 while switch 2 remains in the crossover position, the current will still flow, this time from the black wire to the red wire to complete the circuit and light the bulb. Finally, keeping switch 2 in the crossover position while placing both switch 1 and 3 simultaneously in either the up or down positions will break the circuit.